In this video, we'll be learning how to solve exponential equations. An exponential equation is an equation where you have a variable up in the exponent. So we're looking for some kind of variable or x, or any variable up in the exponent. So an example of this would be 10 to the x equals 100. We notice that there is an x or a variable up in the exponent on the base 10. So we're trying to figure out how do we solve this type of equation when this variable is up in the exponent. We can see the answer there would be 2. 10 to the second power equals 100, but we want to come up with a process for how to actually solve this. So I think about this in a 3-step process. The first part is always get the base and the exponent by itself. On this one, the base is 10. It's already by itself. There's no addition or subtraction, multiplication, or division attached to it, just that exponent. The next thing I would do is convert that to logarithmic form. And then the last thing I would do is solve for the x. So this one's already by itself. So if I want to convert this to logarithmic form, I always start with the base. The base on this one is 10. So I would write this as log base 10 of 100. And then that would equal whatever is in the exponent on this one happens to be x. And you can put that on your calculator, or if you know that 10 is the base right here, it goes in there twice, multiplied. So this answer would just be 2. So the answer for this one, of course, is 2. If you wanted to check that on your calculator, you certainly could. If you just type in log of 100 and then hit enter, it will tell you that it is 2. In this example, we'll be solving for 10 to the 3x equals 25. It's an exponential equation because our x is up in the exponent right there. So we're going to have to use logarithms to solve this one. So the first thing we always want to do is get the base and exponent by itself. So there's nothing attached, addition, subtraction, multiplication, division to that 10 to the 3x. So I can kind of skip step 1 here, go to step 2, convert that to logarithmic form. So we're going to start with the base. So always start with the base, it's base 10. And so I'm going to write this as log base 10 of whatever it equals. The solution is the argument, so it goes on the inside here, log base 10 of 25, and then it always equals whatever is in the exponent. Exponent is 3x. So we have log base 10 of 25 equals 3x. So that's how we remove that x out of the exponent. Now we can just solve for the x. So it looks like we're going to divide both sides by 3. So I'm going to divide this by a 3 here, and this by a 3 here. Now log base 10 of 25 is not a very nice number, so we're going to go ahead and throw that on our calculator, and then we'll divide that answer by 3 to see what x will equal. So let's go over to our calculator and go log base 10 of 25. Log base 10 of 25. Our calculator is already in base 10, so I just did log base 10 of 25, and it equals this 1.39, however you want to round that. So that was that numerator on the top here, log base 10 of 25. Now I just need to divide that by 3. So we're going to divide the answer by 3, and I get 0.47 with a little bit of rounding. So x would equal 0.47. And of course, you can check your answer on this. You could plug in 0.47 in for that x right there and see if it equals 25. I would like you to pause the video and give this one a try on your own, and I'll show the answer in just a second. So here would be the answer, 1.06. So on this next example, we have 2 to the x plus 1 equals 25. First step I always want to do when I'm solving exponential equations, get the base and exponent by itself. The x plus 1, all of that is in the exponent of the 2. So we already have the base and the exponent by itself. So we're gonna skip over that first step on this one. We're going to convert this to logarithmic form. So I always start with the base. So I would write this as log base 2 of 25 equals all of that stuff in the exponent. The exponent was x plus 1. So on this one, that's how I would convert it. And then the last step, solve for x. We're just basically trying to get this x by itself, so we would have to subtract that 1 on the other side. This one's a little bit tricky though, because the base on that log is not base 10, so our calculator, we need to do some fancy footwork there to figure out what that log base 2 of 25 is. So we're going to use what's called the change of base formula that we've talked about before, and if the base is anything other than 10, we would have to write this as log of whatever our number is, log of 25, and then divide this by the log of the base. And if I don't write a little number on the log, it is base 10. Technically, there are little 10s right here, but we can just leave those out if we're just talking about a regular logarithm. So we're going to put this on our calculator, log of 25 over log of 2. This would equal x plus 1. And then we can just subtract 1 from whatever that answer is. So we're going to go over to our calculator, and we're going to hit log of 25. Close that parenthesis out, otherwise your calculator might have some issues. And then we're going to divide this by log of 2. And the base always goes on the bottom for the change of base formula. So that would give me 4.64. So 4.64 is what this logarithm equals, 4.64, and then equals x plus 1. And so now we can just subtract 1 on both sides, subtract 1, and that would give me 3.64 equals x. I'd like you to pause the video and try this one for yourself, and I'll show you the answer in a second. And the answer you should have gotten here is x equals 0.27. So in this example, the base is not by itself. So we have to first get the base and the exponent all by itself. Base and exponent are this 3 to the x plus 1, but this plus 5 is extra. It's not part of the base and it's not part of the exponent. So we need to get rid of that 5 first. So basically we're just going to get our like terms together. So we're going to just move that 5 on the other side. We'll just subtract it from both sides. So I'll subtract 5 on both sides, and then that would give me 3 to the x plus 1 equals, looks like 55. Now I've got the base and the exponent, the 3 to the x plus 1, all by itself. Now I'm free to convert this to logarithmic form. So we'll start with base 3. This would be log base 3 of 55, and then equals what's in the exponent. So this would be x plus 1. Now log base 3 of 55, once again, have to use the change of base formula for my calculator. So I'm going to go log of 55 divided by log of 3. So log of 55, divide that by log of 3. Make sure you put that parenthesis after the 55, otherwise your calculator will stick that second log in the first one and you'll get the wrong answer. So we get 3.64 is what this one is. So let's go back here. So 3.64 equals x plus 1. And then we just solve for x. So we're going to subtract 1 on both sides. And 3 minus 1, that sounds like 2.64. Equals x. That right there would be your solution to this equation. If you want to check your answer, of course you can. Take the 2.64, plug it into the original x, and make sure that satisfies the equation. I'd like you to pause the video and give this one a try on your own. I'll give you the answer in just a second. And you should have gotten x equals 1 for this problem. For this last example, we're going to solve this challenging exponential equation. First thing we want to do is try to get the base all by itself. And the base on this one is 4. That's what's being raised to an exponent. So there's your exponential equation. So we got to try to get that part all by itself. So I'm kind of visualizing like how would I would get this part by itself. I've got an extra, looks like an extra 10 right here and an extra 3. So I'm going to get rid of both of those. So the first thing I want to do when I'm solving is add or subtract any common terms. So I'm actually going to subtract the 10 on both sides. So I'm going to subtract 10 on both sides. And then that would give me 3 multiplied by 4 to the 3x minus 7 equals 9. And so that looks a little bit better. Got some like terms together. So I did any addition or subtraction, not in the exponent. Now I can do multiplication or division. So that 3 in the front, I want to divide both sides by a 3 to get rid of that 3 in the front. So that would give me 4 to the 3x minus 7 equals 3. So now I got the base and the exponent all by itself. So once I do that, second step there, convert this to logarithmic form. So the base is 4, so I'm going to write this as log base 4 of 3 equals all that stuff in the exponent, 3x minus 7. So I'm going to put log base 4 of 3 on my calculator, and then I'll solve for x, whatever that last answer is. So let's go ahead and use the change of base formula, find out what log base 4 of 3 is. So let's go over to the calculator. We're going to type in log of 3, and then divide that by log of 4. Remember, the base always goes on the bottom. So I get about 0.79 for that log. So I'm going to write this up here, 0.79 equals 3x minus 7. And now it's a simple linear equation to solve. We're just going to add 7 on both sides. Get 7.79 equals 3x. And then we'll divide both sides by 3. And I'll go ahead and put that on my calculator and see what that gives me. So over on my calculator, I've got my logarithm right there. And so I'm going to add 7 to that, which I already did. And then I'll divide that answer by 3. And so I get, looks like 2.5, not 2.6, let's say. So x equals 2.6.